All right, today we're going to practice proving inverses using composition of functions. Okay, let me move this out of the way a little bit. So we are going to find f of g of x, and we are going to find g of f of x. Good? So I'm going to take function f, and wherever I see an x, what am I going to do? I'm going to substitute in the equation that's in g. So I'm going to write 3, then what? X plus 2 over 3 minus 2, yes? Okay, what's the shortcut, hopefully, that they taught you in elementary school? There's a shortcut. There's a shortcut right here at this beginning piece. Say it again. I think I heard the correct thing. What? Cancel out the 3's. A multiply and a divide by 3 cancel each other, right? Multiplying, dividing by the same number cancels. So that leaves me with x plus 2 minus 2. And that makes a 0, which leaves me with x. Because 2 minus 2 is 0, yes? Do I need to raise the screen? Okay, you can see that? Okay. So now we're going to do the same thing. We're going to do g of f of x. So I am going to do 3x minus 2 plus 2 over 3. Again, I took this and substituted it right there. I took this and replaced x. I took the f and put it into the g function. Okay? So now, that cancels, yes? And I'm left with 3x divided by 3, which is x. Are they both x? Therefore, they are inverses. Okay, good. I'll give a couple seconds because some people are still writing. And then we're going to have another example for you to do. Okay, so I had a good question. Just people are trying to clarify what's going on. So when I have f of g of x, my main function is f, and I'm going to plug g in. Whatever's in the parentheses is the one I'm substituting into the function. Here, the main function is g, and I'm going to plug in the f of x. Okay, let's try another one. All right, so we're going to start with f of g of x. Once I select pen, f of g of x. Who would like to tell me what I should be writing on my paper? What's the main function? F is the main function, and I'm going to plug in g. So instead of writing x, what am I going to write? Not square root, cubic root of x minus 1 cubed plus 1. What do I know about cubic root and cubed? They cancel, leaving me with x minus 1 plus 1, which is x. Good? Well, that would be the end, the final for f of g. So now I'm going to come over here, and I'm going to do g of f of x. What is my main function? G. So cubic root of x cubed plus 1 minus 1. Okay, what happens to the plus 1 minus 1? Cancels. What is the cubic root of x cubed? X. They're both x, therefore they are inverses. Okay? All right. Okay, so this means with the open circle, f of g of x. It is the same as this. And this is the same as g of f of x. All right? So, f of x happens to be 6x squared, and g of x happens to be 14x plus 4. F of g of x, which means I'm going to take function f, and wherever I see x, I'm going to plug in the g. So that's going to be 6 times 14x plus 4 squared. So 6 times 14x plus 4 times 14x plus 4. Using double distribute or FOIL, whichever you're comfortable with, 196x squared plus 6, carry the 1, 56x plus 56x plus 16. 196x squared plus 112x plus 16. Now multiply that by 6. Okay, so that's 6 carry the 3, 7 carry the 5, 1,176x squared plus 672x plus 96. That is my final answer for f of g of x. Okay, pause for questions. All right, now we're going to look at g of f of x. So I am going to take function g, and whenever I see x, I'm going to plug in function f. So function g was 14 times a 6x squared plus 4, which is 84x squared plus 4. What do you notice? What do you notice? They're not the same. Okay? So therefore, they're not going to be inverses. Good? All right. Let's look. Number 8 has 2 problems. I would like to look at the more complicated one and have that one on our video, and then the easier one I'll still do. Okay? Okay. When fractions are involved, it can get a little messy. I'm going to start with f of g of x, and it should look like this. 2x plus 3 over x minus 1 plus 3 over 2x plus 3 over x minus 1. And then it is minus 2. Okay. Now this gets complicated. Think, you cannot cancel because this is a whole item of together. Okay? Who remembers from Algebra 2, how do I clean up just the denominator? I want to get rid of a denominator in the denominator. What do? Multiply by what? Okay. All right. Okay, so I'm going to multiply by the denominator. When I distribute this, when my numerator and denominator are the same, I can cancel. So on the bottom, I now have 2x plus 3, and now I have to distribute this, minus 2x plus 1, because negative 2 times x is negative 2x, negative 2 times a negative 1 is a positive 1. So that is my denominator. Okay, listen again. You've got to stop the side conversation. Okay. You multiply by the denominator because that will put x minus 1 in the numerator and the denominator, and it will cancel it. Florence. Okay, so there's a couple confusions going on. Let's time out for 1 second, okay? F of g of x, yes? Let me just, okay, f of g of x. So I took function f, which was x plus 3 over x minus 2. And every time I see an x, I'm going to plug in 2x plus 3 over x minus 1. We good? Okay. Now, I have a fraction in the denominator. To get rid of it, I multiply by the denominator of that fraction, which happens to be x minus 1. When I distribute that to this fraction here, it cancels and leaves me with the 2x plus 3. Then I distributed it here, which is negative 2x plus 1. Okay? Now, up top, I'm going to multiply also by x minus 1. Okay? I have to do what I do to the bottom, I must do to the top to keep it fair. So this is really x minus 1 over x minus 1 is multiplying by 1, so it doesn't change the problem. Okay? Question. So, when I multiply the x minus 1 times this fraction, I keep the numerator because it cancels. Then I have a negative 2 times x, which is negative 2x. And I have negative 2 times negative 1, which is positive 1. I have not combined like terms yet. Negative 2 times 1. Negative 2 times a negative 1. Okay. Oh, sorry. I see what you're saying. This should be a positive 2. Sorry. Okay. Sorry. Good now? Is that what you're trying? Okay. Okay. So now we're going to distribute up here. What does that give me? 2x plus 3 plus 3x minus 3. Okay. Good. Now, let's clean up the numerator. What's the numerator cleaned up? 5x, because this cancels this. Okay, clean up the denominator. What cancels? 2x is canceled, leaving me with 5. What is 5x divided by 5? X. Shh. We are halfway done the problem. Yes. So this is f of g of x. Now, shh, g of f of x. Shh, calm down. So now I'm going to do 2 times x plus 3 over x minus 2 plus 3 over x plus 3 x minus 2 minus 1. Hold on. Okay, what am I going to multiply top and bottom by? X minus 2. Okay, that leaves me with 2 times x plus 3 plus 3 times x minus 2. Okay? And on the bottom, it leaves me with x plus 3 minus x plus 2. 2x plus 6 plus 3x minus 6 over 5, because these x's cancel. The 6's cancel. 5x over 5 is x. Because they're both x, they are inverses. Time out.